So I get to go old school.
All right. And this is my good buddy, Scott Roberts. He is one of the DFIR engineers over at GitHub. He is S. Roberts on Twitter. If you feel like, actually, you don't tweet much, so if you feel like silence, follow him on Twitter. And like Heroku, they also have tens of thousands of servers in production, but for purposes of Osquery stuff that we'll be talking about, let's talk about the hundreds of Mac clients that they have. So Osquery, this is going to be a story told in 3 parts. We're going to start by talking to you about what exactly Osquery is even, talking a little bit about how to use it, and then once you're familiar with how to use it, how to bring that up to big scale, like tens of thousands of servers, as we've talked about. So what the heck is Osquery? In a nutshell, it is a way of getting information that you can already get off of your servers, but in a nice, uniform, and consistent place. It exposes system information as if it was an SQL table. And we're all, well, I shouldn't say all, many of us are familiar with SQL. And so rather than having to remember all the different utilities you can go to find certain information about your system, you can go to one place to look for the users and the groups and the installed packages and stuff. Osquery also gives us the really helpful ability to schedule these queries, run them over time, and bring the results back to some central place, which is great if you want to find changes on a system. You have a list of users on a system, and then you can just, for example, bring that into Splunk and have Splunk tell you, hey, for some reason there's more users on a system than used to be there. The people responsible for this are Facebook, specifically Mike Arpaia and Teddy Reed. We just checked on this morning, actually. There's 95 contributors to this project. It's a very active project, very healthy project. Facebook.
Last commit was 16 hours ago. So
right.
not just sitting around going bad software.
Exactly.
So when you start off with Osquery, you know, it's easy to say how it does things, but how you use it is a different thing. There's 3 kind of key tools you're going to use when you get used to Osquery. The first one, and this is kind of something I don't know of any other incident response tools doing, is Osquery I. If you're familiar with Python or Ruby, you know, you can type in Python and you get dropped into a REPL, a read, evaluate, print loop, where it lets you kind of execute a command, immediately see what it gives back, and kind of build from there. Osquery actually lets you do the exact same thing, but for your system state. So you can run a query. It's like being able to execute an antivirus search just once. See what comes back and refine your query. So it's a great way to get familiar with the tool. It's a great way to start testing. We even use it a little bit for doing one-off checks on specific things. The real power of Osquery is when you get to Osquery D, and that's just the daemon. So that's where Osquery gets a configuration. It runs continuously, feeds results back somewhere, remotely, locally, things like that. It takes a little bit of setup, and we're going to talk about what it takes to get Osquery D started, but this is where the real power of the system is. And lastly, you manage Osquery D using another utility, Osqueryctl, turn it on, turn it off, get status. And this is great because it takes care of the fact that different operating systems do different things to start up a daemon. So on OS X, it takes care of launch control. On, well, Linux has so much variety on that, but it just takes care of all that for you.
All right, let's talk about how you actually use Osquery a bit. This is a beautiful, and I bet nobody can read this, so I apologize. Who can't read this? Anybody who cannot? Okay, since you can't read it, I'll give you a shirt. So that's my apologies for that. But this is what the REPL looks like that Scott was talking about. It just gives you a nice little shell like this, but you can start entering queries into that. And since we, like I said, most of us are familiar with SQL, we'll just start with something really, really simple. Here I have a query to select star from app sources, and that's going to get you all the information about, you know, the app sources. So really basic, easy to understand. You can get a little more advanced, though, like you can with SQL. So here we have one, for example, it's going to find any kernel extensions that were not apple.com kernel extensions and stuff. And then it'll show you a nice little table of this. And this is great for when you're actually looking at a machine. But again, I feel like the real power of Osquery comes in those scheduled queries that can be doing this and sending it back to some kind of log collector. Really, though, the power of SQL is when you start getting into joins. So here I'm taking, for example, the listening ports and also the processes on the machine and doing a join on them to get all of the PIDs and the names of processes that are listing on a particular machine. And I think any of us that have done incident response would say that's useful information to be collecting on a regular basis.
You mean everybody hasn't memorized all of LSOF?
And no one should have to. So. We have some examples here. I'm not going to go through these. You guys are, I'm sure, all going to want to go back and look at our slides afterwards to get these queries. And actually, we're going to talk a little bit about why you don't even have to memorize these things. But I just wanted to show like some of the stuff that you can do where you start, doing some joins and filtering on certain results and stuff like that.
And so the whole move between different types of queries and going into those advanced ones is really about query philosophy. And this is one of the options that Osquery gives you that a lot of other tools will have kind of made a decision for you. With Osquery, because you can spend a lot of your time writing your own queries instead of just relying on ones that you get from a vendor or something like that, you can take your own approach based on your own environment. Kevin, because they're mostly, I know.
Yeah, wow, mic pop there.
I got excited. Kevin, working for Heroku, they're managing a lot of servers, they're highly uniform, so they take an approach of getting back lots and lots of information, pulling it back and doing post-processing. We kind of think of this as the haystack approach. Get as much data as you can, and then figure out what to do with it. At GitHub, we're running Osquery primarily on user laptops. As a result, we have to be really targeted because we have to pay attention to user privacy. And so the great thing about Osquery is, unlike Kevin, who wants to get huge swaths of information, I can write queries that look for just individual specific things that are high fidelity indicators of compromise. Two different approaches, they fit two different environments. Osquery goes actually beyond the SQL format and actually has a couple extra things that are useful. Adhoc queries, so you can have groups of scheduled queries that are going to run continuously. You can also have ad hoc queries that will run once. And what I love about this is it gives kind of a sweeping capability to Osquery that you might not have otherwise. You can pick a specific query, run it across your entire fleet, it runs until it's gotten everybody in the fleet, and then it comes back. So we were really dying for this during, does anybody remember the iPhone SDK compromise? And we were literally going back to users and saying, hey, did you by any chance visit this website? And we would have been able to figure out everything just using a single ad hoc query instead. Osquery can do file integrity monitoring. You can set a directory. It'll essentially fingerprint those files, let you know if anything changes. And last but certainly not least is Osquery is actually will actually let you do Yara signatures and send back information where a Yara signature triggers. So this gives you another kind of more malware-centric detection capability. Osquery D is managed through three particular files. So you'd start it up using the osquery.ctl or CTL. The configuration file is where you put all of your queries. So this is where you set, I want to run select star from kernel extensions, things like that. Osquery flags, which essentially tells Osquery how to run. So how often to execute, how often to look for updates, things like that. And most importantly, where do the logs end up going? And then, this is kind of a little bit of a side note, but this is where it fit best. Managing intelligence with packs. So those advanced queries that were shown, Kevin's mentioned, you don't actually have to write them yourself. Facebook came up with an idea of bundling groups of queries that a lot of people might want to use into what they call packs. So these are related groups of queries. They live on the file system, they run with their own set of schedules. They're kind of useful. Kevin and I both actually brought this up, and when we were talking through our talk today, we both said, yeah, they're useful, but we don't really use them, simply because they tend to become a management frustration.
Well, especially because, so here's specifically why Heroku doesn't use them, and I use them as more of a guide. I definitely look at them, but again, I mentioned tens of thousands of of servers that are all as uniform as possible. But they're uniform between a class of servers. So all the web servers are basically the same. All the database servers are basically the same. But a web server is not a database server. So it's not like all of them are the same. So one of the things that I've had to do is I'll take the queries that I'm writing and then I'll add in a little bit of extra SQL to say, like, I also want to have a column called just the class of this machine, and it'll just fill it in with like web or database or something like that. And that makes, and a good example I think that I can think of for that would be like a lot of, we get a lot of, like we should very rarely see file system changes to the authorized keys file on a machine. So generally across the board, I don't want to see that, and I'm going to alert on that. But on our Bastion host, we actually do require those keys to change pretty frequently. So I don't want to just write an alert that's going to blow up every time any one of our employees goes through natural key rotation. So I have to be able to differentiate between the type of server. And if I'm doing that, I can't do that with just like a general query pack across the board. I need to actually be customizing those in some way.
Yeah. They're an interesting capability that has some uses, but also has some limitations.
I think it's just a great book of ideas.
There you go.
Yeah. So let's talk about using Osquery at scale. And I kind of just gave away like what do I do for Osquery at scale. But does anybody have any questions, by the way, real quick? I'm just going to quick pause for, no? Oh, we're supposed to do that at the end? No questions, sorry. Okay. All right, so we've already kind of talked through this. How are we using it at Heroku? We put it on all of our servers. The environment is very uniform by type, and then we just look for things that are not uniform. I've spent a lot of time working out what are the file system changes that I should expect to see on a runtime, and then I can alert anytime I see something that is not that. And we do some lookup of IOCs, but that's really not so much because I need to know what it was. It's more of like a heads up to help my investigation move forward. Really, anytime I see one of the unexpected changes on the file system of a server, that's an incident of some kind. It may be that somebody's trying to do some hacking. Much more likely that somebody just was making a change outside of change management, but either way, it warrants an investigation. So just knowing the IOCs where we do lookups, it's really more just like here's a heads up.
At GitHub, we picked Osquery primarily because it's one of the few systems that works really well on OS X. At this point, actually, Osquery itself is OS X and Linux only. There was a project by Trail of Bits where they were trying to move it to Windows. I don't actually know what the status of that project at this point is. So we picked it because we're an OS X shop, and we needed OS X support out of our tool. We use it very specifically for hunting known IOCs. So whenever any new information comes out about people attacking Macs, the first thing we generally do, take it, figure out how to write queries against it, and then push that out to all of our endpoints. And we also use it a little bit for verifying configurations, things like making sure everybody actually has full disk encryption turned on. It's still a work in progress, but it's when we first started talking about this, we were just barely rolling it out, and now it's been in production for a few months and going really well.
So earlier, Scott mentioned that there's this file, osquery.conf, which is used for actually holding the queries that you want to run. And when you start trying to do this across tens of thousands of servers, that gets to be a real pain in the butt to manage that file, especially if there's going to be different queries run at different intervals on different types of servers. The good news is that configuration file can come from an SSL server. Yes. So, and that server can receive the logs as well, which brings us to Windmill, developed with love by Heroku and GitHub, specifically us, really. Yeah, pretty much
just us.
No. There've been a couple other contributors. Come on, we can't shortchange them. Okay, so what the heck is Windmill? Well, the Osquery logo kind of looks like a pinwheel thing, so we decided you named it Windmill.
Naming stuff is hard.
Naming stuff is hard. Basically, it's a Ruby server that gives you a TLS endpoint that all of your Osquery clients can check in with. They register with the server, and then the server will say, oh, you're a web server. You should be getting this configuration. And then they can check in. You can set an interval. I think we've set it to like every 5 minutes or something to check in and see like, hey, should I be getting a new configuration file? And it'll say yes. So that's great. If I need to make a change to one of my configurations, I can change it on the Windmill server, and then within 5 to 10 minutes, all of my thousands of web servers will have checked in and grabbed that new configuration. It is open source. It's on GitHub. It organizes endpoints into configuration groups. That's what we kind of call the different classes of servers. And it can, as you mentioned, it can also receive and forward the logs. We designed this to be very, very focused on safety, though. One of the big deals was having versioned configuration files and being able to do canary deployments. So a canary deployment is where I take a new version of my configuration and I can say, I only want to serve this up to a random selection of 5% of the runtime servers, for example. And then I can monitor them to see that I haven't written a really expensive query that will potentially take that machine down. If I don't have any problems, I can keep turning it up, 10%, 25%, until eventually I'm at, okay, I want 100% of the servers in this configuration group to be receiving that configuration file. So what now?
So the whole idea of, thank you.
Yeah, you got to hold that.
I do. So Osquery itself gives us the endpoint piece. It gives us the thing that sits on the box and gets us telemetry. Windmill adds the ability to manage that endpoint and then receive the telemetry from that. From Windmill, you can kind of do whatever you want. At GitHub, we take it forward into our syslog infrastructure. It gets filtered into Splunk. It gets filtered into Elk. And from there, we start dicing up the data. It's really easy to work with. They just throw off JSON because no one likes XML. Does anybody like XML?
Who likes XML? One? All right, you
know what? No, you do not. I do not believe you. I do not believe you.
I will give him a shirt for, there you go. Oh, what a perfect throw, too.
I'm going to remember that one.
Was there a second one? Oh.
He's just lying for a t-shirt.
Let's talk later. You can't take the medium? Who's a medium-sized man?
There you go.
All right.
So that analysis lets you then take and push your Osquery data into any of your other infrastructure, whether it be log management, whether it be a SIM, however you work with data, Osquery can get there. So some resources if you want to get started. One of my favorite things about using open source tools like this is you can literally be sitting there and just decide you're going to start playing with it right now. Osquery.io is Facebook's website. They give a ton of information, a ton of documentation, a lot of explanation about what's going on. It's on GitHub under Facebook/Osquery. They even have a Python module, so if you want to extend Osquery, but you don't want to write C, because no one wants to write C, you can do that. The Windmill tool is on GitHub as Heroku/Windmill. And also, Mr. Thompson, an ambitious lad that he is, built a tool called OSQ Simulator, which lets you test a tool like Windmill by spooling up thousands of faked Osquery endpoints. We should be honest, we're actually not the only game in town when it comes to doing Osquery management. A lot of other people recognized what a great tool this was and got on board. Doorman and Collide are probably the two biggest ones right now. They're also worth looking into.
Yeah, I mean.
Yeah, I guess.
But only one of them is giving away T-shirts up here, so. Yeah.
Make decisions as you will.
Mm-hmm, exactly.
So
to summarize, we talked to you a little bit about Osquery is a tool that exposes lots of different system information as SQL tables and gives you the nice SQL syntax to query them from. We talked specifically about how to use Osquery, specifically how to configure it and how you can do remote configuration, and that's where we got into using Osquery at scale. Go ahead and advance the slide. I don't have the thing. Are there any questions?
So when, in terms of what you're pushing out to syslog and to your SIM and stuff, what are you actually sending to it? Is it just query results? And if so, does it send something with it that says what the specific query was that ran?
Yeah, so when you set up your osquery.conf file, which we thought about showing you, but sitting here and doing 20 minutes of showing you JSON files wasn't going to do very well for our reviews. The JSON, or the osquery.conf file includes a name of a signature, what the actual signature is, how often it runs, and then also some metadata. And so what you'd essentially get back is, this was the name of the signature that fired, and then here are the results that came back from it. So you end up getting both sides where you'd know what triggered and what the results it triggered came back as. Essentially, it's giving you the JSON representation of that SQL result.
I think it's worth mentioning that you get one log line for every row of the results. And then each of the row is still going to include that information about what was the name of the query that fired. So you get the timestamp, the name of the query. And so if it was something like 5 results, you're going to get 5 log lines back.
correlating it back has never been a hard issue.
Any others? Oh, yes, sir.
Are the results live, or are they saved on the server?
On the server that sent them,
Yeah.
that's going to depend on what you set your log destination to be. So if you choose to send them to syslog, they're going to sit in syslog on the server. If you choose to send them to an HTTPS endpoint, then they're going to go there. And I don't think it would still write them to the file system in that case.
So no.
No, I'm wrong?
We actually at GitHub made a particular request to the Osquery team, which was we wanted the ability to write logs to 2 different locations. Simply because in that whole kind of user privacy idea, we wanted people to be able to go and look at what were the logs collected on their machine, but we also wanted to have them sent out so we could use them remotely. So Osquery does support the ability to have 2 loggers going at the same time. So in our case, we configure it so one writes directly to the file system, and one writes out through syslog. So we're able to get the best of both worlds. And I think you could configure that with other loggers in different ways if you wanted to.
Okay, but out of the box, it wants to write to one destination?
Out of the box, it depends on how you configure it.
Yeah, I suppose. Okay, yeah, good point. What else? Another? Oh, yes.
So the data that is collected is strictly based on what you've got in your conf file?
What you've got in your conf file or what you are getting remotely through remote configuration. So yeah.
Okay.
The one exception to that actually being packs, because packs can stay on the file system and be consistent. But
what are you having to have server-wise be able to receive 10,000 nodes worth of data? I mean, what are you actually putting up that can retrieve and store that much data?
So at least at Heroku, our results are all going directly into Splunk. Not directly into Splunk. We actually have it configured to write to syslog, and then we have a thing that grabs syslog and moves them over to Splunk. As far as the system that handles up those TLS configurations to all of them, we do that with a shockingly small server. So Heroku has this concept of dynos, and I think we use basically one, I don't think we're even using a performance dyno. We're using like one regular dyno, and that's capable of serving those configurations to our whole fleet.
we manage our configurations using Heroku. We pay $7 for our entire infrastructure.
So second question is, and I think we've talked about this, Scott, why did you use this over GR?
Sorry?
Why did you choose Osquery over GR?
Overheard?
Over GR.
GR. Excuse me. So I like GR. We do use GR for specific investigations. Personally, I look at endpoint telemetry as falling into kind of 3 categories. There's alerting, there's sweeping, and there's remote forensics. Osquery is great for doing alerting, and it's good for doing sweeping. I think GR is good for doing sweeping and great for doing remote forensics. If I had somebody, if one of my users in Europe got popped and we wanted to do a deep dive into their system, I'd probably have them install GR, and we'd use that. But for day-to-day alerting and basic sweeping, Osquery does what we want, lower performance, lower chances of abuse, which is probably our biggest thing. So the other thing I like about Osquery is it's able to be very transparent. If we'd used some other vendor tools, we couldn't necessarily say, here's everything that our system is looking for on your system. We manage our configuration, this is going to surprise anyone who knows GitHub, in a Git repo. And so when my users want to know what I'm looking for the new threat that just came out, they can literally look at the last pull request that got merged. And that level of transparency was one of the reasons that Osquery was a no-brainer for us.
Kevin, can you do that GR pose again? My camera wasn't ready.
Oh, sorry. 5-second pose for the benefit of those of you that have flash photography.
You look like a tiger middle manager.
That's awesome. Thank you.
Any other questions?
Ladies, I have 2 shirts up here that are in women's cut. Just letting you know. Maybe you have a question. Yes, I have a question over there. You know what was even better was the question. So, what was the question? She just asked, can I have a shirt, right? Okay. Who wants to like be responsible for passing this tour? Because I really don't want to try to throw it that far.
I really want you to try to throw it that far.
Should I try it? Okay, everyone cover your beverage, okay? Cover your beverage. All right. I got one more lady's shirt up here. Who's got a question? Preferably not one that's already been asked. Yes, ma'am. You know what? That was awesome.
I have stickers.
I also have stickers.
Thank you so much. We really appreciate it. We'll be around if you have any more questions.